Cisco's virtual CMTS. No GUI or no CLI? We're going to find out. I'm Brady Volpe, founder of NimbleThis and the Volpe firm. This is episode 76 of Get Your Tech on, our show on all things DOCSIS. With me today are two great guests. First up is John Downey, CMTS technical leader at Cisco Systems. John, welcome back.
Good to be here, as usual.
All right. And next up is Jason Miller, Technical Marketing Engineer at Cisco Systems. Jason, good to have you back. Been a while, Jason.
Good. Yeah, thanks. Good to be back with y'all.
Yeah. So, Jason, it's been a while. We were on a panel at ANGA COM at their virtual conference, and we were talking about a number of things, one of which was virtual CMTSs. I got really excited to hear that Cisco is working on virtual CMTSs, something I actually did not know about. So I thought it'd be great to put this show together specifically to talk about what you guys are doing in that area. A lot of folks actually don't know you guys are working on this. So I think we'll just kind of jump right in and get a little bit of history about, let's actually back up and talk, what your topic was at ANGA COM. John and I did a little coverage of that last time. But at ANGA COM, you were talking a little bit about, kind of what you're doing in that arena. And again, I was kind of surprised you were doing virtual CMTSs. So what was your topic at ANGA COM again? And that'll be how we lead into this.
Good. Yeah, on ANGA COM, what we were kind of talking about wasn't so much about the product, but probably what some of the changes involved for a customer when they're actually going to start using that product. So there is some inherent things that are different about using a virtual CMTS and what you might do with a chassis-based one. And that was some of the points that we covered at ANGA. One of my colleagues covered the move to Remote PHY. Obviously, when you move to a virtualized CMTS, you need to run to some type of distributed access architecture. For us, it's Remote PHY, what's deployed today. FMA, options down the road. But those are big changes. So there was some of the things about that. What I was talking about was actually changes that are done when we're actually interfacing the virtual CMTS itself. For Cisco, we elected to kind of change how we were going about doing things. We now interface it with using stream and telemetry in a dashboard. We use APIs. So there was a lot of changes like that I was highlighting on that when we did that the session together for ANGA.
Yeah, it was a fun session. I mean, we covered a lot of different things. We even talked about like green technology and stuff, which I think virtual CMTSs really fall into sort of that green technology, moving from a large analog CMTS and analog optics into virtual CMTS and remote PHY. So the whole green segment of that was also interesting as well. But getting into this whole concept of Cisco doing a virtual CMTS, again, was surprising to me. So do you guys actually have a virtual CMTS?
Yeah,
it was never a secret.
Yeah,
I know.
It was just kept from me. You were hiding it from me. So John, you said it was never a secret. I mean, so when did you guys actually start getting into the virtual CMTS?
It had to be over 5 years.
2016 was the first time that we kind of actually had some things that we were demoing at one of the SCT expos. There was the one in Philadelphia. I think that was 2016, but I kind of lose track. Yeah.
So,
and yeah, I just even say on the first one, the kind of what I was talking about, the whole thing as Remote PHY started coming into more of something that was deployable, it became apparent that if you have a CMTS chassis with some type of GIGI coming in and some type of GIGI coming out, that you no longer are tied to have to use ASICs and FPGAs and other kind of specialized equipment that we need to get RF connections out of that platform. And once you do that, that becomes an opportunity now of porting that software that was doing the CMTS control onto some type of general compute resource. And that's what we showed on the 2016. The benefit being there that if you could separate the hardware from the software, then you can, as the new hardware processing equipment comes out, you could quickly jump onto that. Where today, when we're more of a chassis based, there's a lot longer lead time before we can integrate a new processor into our platform, because we have to productize it into a supervisor and all that kind of thing.
But you're not talking about just extending the capabilities of the Cisco's CBR8, right? You're still
Right.
talking about a
Actually,
different
that was
product.
right. That's a good point. So that's what we did initially because there was, a quick interest that, hey, we want to see virtualized. We want to see what this is. And I think that's for us, that was a virtualization. We took the iOS software, virtualized it, put it on a VM, and we separated the hardware and the software from that. You get the benefits of, of being able to use the new hardware and all that kind of thing. What you don't get though is you still end up with somewhat of a monolithic software feature where it becomes more difficult to add new features. So, you always have these things as far as if you add a new feature here, you need to make sure that it doesn't create any kind of problems with other components. And when you move more to what we call cloud, cloud-based type products, when you move to that, well, then that's a different architecture. So that's ultimately what the product that we talked about at the ANGA show and the product we have now is, we call it the CMBR, Cloud Native Broadband Router, but it takes advantage of those microservices and basically rewrote the entire DOCSIS, portions that we did on our CMTS.
So your first step,
And Brady,
yeah, go ahead, John.
yeah, I mean, that was kind of the point I was trying to make before, where, people are using the term virtual very loosely now. And we used that term at the beginning. We pivoted and said, no, we need to go cloud native and totally rewrite everything to have containers and all this other stuff. I don't know all the terminology, Kubernetes, containers, JSON file, whatever. But it's not semantics, right? I mean, but people are using the term virtual just to mean generically the whole thing. But originally we moved from virtual to cloud native, and there was a difference.
Yeah, and I think I mean I think the terminology and Jason kind of you said it quickly, but it's kind of important what you said. You took the iOS, which is the operating system in your CMTSs, and you put it on a virtual machine. So you basically put it on a server, like just
Right.
a computer.
Yeah.
And that was kind of your first step, and that's the virtualization part. We
Yeah.
we talk about cloud and these like kind of nebulous things that people have a difficult time sort of wrapping their heads around sometime, but taking the operating system out of your CMTS, which and I'm going to give Cisco credit. Cisco basically created the first CMTS that was compatible with a DOCSIS specification. I think it was like the 7246, that the original one,
Yeah.
that everyone kind of grew up on the CLI and understanding it. But you took that software operating system and put it on a server. This is kind of what you said, right?
Right.
And then from there, John, you were mentioning things like Kubernetes and Dockers and so the monolithic part, Jason, is like taking that operating system, and that's kind of like when we think monolithic, we think like Microsoft. That's a monolithic operating system. And so if you were to take your iOS, that's a monolithic operating system. The challenge is you have with a monolithic operating system, if you want to make like a small tweak here or small tweak there, you make one code tweak in this huge monolithic operating system, and you can break something someplace
Right.
else and everything crashes. And then what, John, you were saying with like Kubernetes and containers, the reason software people like those environments is you take this monolithic software and you break it up into small little components. So and put it into containers. And so let's take something like like the RF portion, or maybe like a Mac controller, just like one small section of that monolithic thing. So if I want to make an adjustment to the way that timing works in a Mac controller, and I make an adjustment there, I'm not going to impact something, another aspect of the software application. And then Kubernetes just stands around and it monitors all the containers and makes sure that they are all up and running. If one of those containers crashes, Kubernetes comes in and restarts the containers. So that's kind of that's what you have going on, right?
Yeah, good point. Yeah, and if you would have seen, like you said on the first one where we just virtualized the iOS, the command line was the same command line. Everything would have been looking the same. Obviously, it was remote PHY based because it has to be virtualized. But you're right. As we moved on to container based, and that's why we chose the name of a cloud native broadband router, because it is built in the same kind of software models that they would do if you were deploying something in the cloud. Our intent isn't necessarily that someone's going to deploy a CMTS in a cloud somewhere. but the software is written where that has the resiliency in the software, where, like you said, Brady, with the Kubernetes and restarting and those type of things, where that's where the resiliency is. Where today on the CBR8, the chassis-based platforms, the resiliency is in the hardware being highly redundant. When we move more to the other ones, then the resiliency is more in the software. And if a server fails, we have ways to deal with that.
So what's the benefit for a cable operator? Like, I mean, we talk about this cloud stuff, but what would be the benefit of a cable operator to host? So the CMTS conceptually now is just running on a server. It's not running on a big box. It has to have lots of power, lots of cooling, lots of rack space. So we can consolidate that into just a small, like a 1RU or 2RU server, right?
That's right.
What's it matter whether
certainly some of that?
Yeah. So what's it matter if the cable operator has that server running in their head end or has it running in the cloud? And when we say cloud, it's like an Amazon hosted service or Google hosted service or Azure hosted service.
Yeah, there's some looking at maybe of having that. Certainly today, the model is that it's going to be running on the cable operator's premises. Right now, for us, the control plane runs through that, the CMBR, so does the data plane. And you wouldn't run that necessarily out into the cloud. You'd have to wait until you ship more of the data plane out of there before you would probably do that, or else you're going to have a lot more, capacity wise into the AWS. I also think even we had looked before at maybe having a hosted CMTS where someone else would operate it. And even the smaller operators, their DOCSIS service is a very good business for them. And I think all of them wanted to keep that platform close by.
Right.
So I think that was what I think a lot of people have been more anxious just to keep it that way. And I think we're probably reluctant to use something that was maybe had to run in the cloud versus maybe an option to run in the cloud.
Okay. So, I mean, we've had, and John's been part of some episodes where we've had other vendors on with virtual CMTSs, and they have their reasons for, they say, well, we think virtual is better for X, Y, and Z reasons. So what's kind of driven you guys to look at virtual CMTSs and say this, maybe this is a better way to go than the traditional hardware, large CMTSs that you've traditionally always used?
Yeah, I think for us, we want to build CMTS that people want to buy. I don't think it does anyone any good to build the best CMTS that no one either wants to buy or can afford. So I think there was a movement in the cable industry with, again, distributed access architectures that, hey, we want to explore virtual CMTS. So I think when there's a movement to that, there's certainly an interest. I could tell you from some of the CBR8 product, for example, the density that we have in our current line cards, even iCMTS, I don't think anyone has gone beyond that need for that type of a density. But where Cisco gets some benefit on that is as we move into DOCSIS 4.0 and these type of things, we're talking about a real big capacity increase per service group. Ultimately, the chassis are built where the line cards and the supervisors have some kind of throughput that they have per line card. And if we have, structures that it does 8 service groups per line card, and it can do this amount of capacity, then when you make these jumps, you have to have additional soups. You have to have different type of line cards. When you move into a model of it's virtualized, well, now it's a lot easier to do that scaling because you can kind of scale a lot of that independent. You have, compute resources like how many service groups you can support, and then you have network resources on, how fast you can get in and out of this box, so that what kind of densities you could do per service group. So as you get, not so much now, but as you get into some of the next jump that maybe, wherever DOCSIS 4 might be, you're going to need to make those kind of jumps. And I think for Cisco, and I think for other vendors making a virtual CMTS, those kind of jumps are a lot easier when things are on general compute type servers.
Right. So, John, you're normally like you're the balance here, and so have you had time with your hands on Cisco's virtual CMTS, and from that perspective,
we talk about containers and putting features into smaller containers. I deal a lot with load balancing, resiliency, partial mode. things that the RF plant screws up the modems, and the CMTS has to try to mask those problems, right? If I have a fix or a bug fix, do I upload new iOS that went from 23 megabyte file to now it's what is it now, Jason? Like
close to a gig, I think.
Gigabytes.
Yeah.
And iOS is huge. I mean, it is huge. We added so many new features, right? 3.1 and all that. But every feature has code, and any little change affects the entire thing. And engineers think, well, why can't the MSO just change the iOS? I'm like, you don't understand. They have a small window of time to do a maintenance window, and you're asking them to do 4 CMTSs a night, and they have 500 CMTSs. By the time they do all the CMTSs upgrade, it's time to upgrade again. So it's just like it's a constant, movement. So yeah, it can take a while, right? So now that we make it cloud native and maybe just small little tweaks, and we can even upload new code for BGP or something like a routing protocol to one RPD and say, hey, let's see how that goes for the next 2 days before I do it mass wide, So I mean, I think that's kind of cool. The other thing I wanted to point out was it's no secret that Cisco is pushing more software markets or business versus hardware. Hardware starts getting commoditized, I think. So then more people get into it, you don't make as much money on it, whatever. So to add on to what Jason was talking about, it just makes sense to go the direction. It's also Cisco's direction has been more software. So when people keep asking me, is Cisco getting out of cable? I'm like, no, Cisco is not getting out of cable. We're still doing cable, but we have the RPD, we have optical nodes. To be brutally honest, I thought we would have got rid of the passives 5 years ago. I was surprised we actually held on to taps and things like that for so long. So, the amplifiers and stuff we're pushing out. We partner up with ATX and other people that are still doing amplifiers and taps and all that stuff. So now that I tiptoed around there, what was the actual question?
Well, I mean, what's your perspective of a virtual CMTS versus a big iron CMTS, an analog CMTS? Huh?
So I know where I was going to go with that is about partial mode and load balancing. This is a cool thing. Now that it is cloud native, there's no real bonding group assignment like we do today. Like we make static bonding groups. We have this new feature called dynamic bonding groups where once the modem comes online, it says, hey, I have an 8-channel capability. The CMTS will make an 8-channel bonding group. That's kind of in the background. Now the modems, we know what the capability of modem is, and out of 32 single carrier QAMs, it could pick a bonding group or whatever it needs to do the service flow on.
Could it do 31 channels if one's impaired?
Yeah, so instead of even going to a partial mode, it could just move to a different 8 channels. Mm-hmm. I mean, I could take this a step further and eventually keep a historical historical information, and maybe do AI or machine learning or whatever, and say, well, this modem's always had a problem with this frequency. So, out of the 32 frequencies, don't even try to use 865 megahertz or 861 megahertz because he always has a problem with it. So, but instead of dropping him to 6-channel bonding or a 7-channel bonding partial mode, just move him to a different 8 channels. So the new code and the new software would almost alleviate load balancing and partial mode, I believe, because of how it can assign the downstreams on the fly to different service flows. So there'd be some more functionality, and I think it'll make things better for speed-wise, because I'm always worried about what happens when the RF plan is bad, what happens when the modem goes to partial mode, what happens when I get CM status messages, does it come in and out of partial mode? So yeah, but you were actually, this whole talk, you were going to go more down the line of GUIs. Now that's the part.
Oh, I got those questions queued up because those came from the ANGA COM show, because you're threatening to take away my GUI. But
all of us.
So I mean, you're
here. We know CLI.
Yes, we're very CLI oriented, but because the virtual CMTS is running on, I don't know if it's an Intel-based server or it's running. I mean, you're probably running, and you can tell us it's an Intel-based processor.
Yeah.
I mean, these servers, I would imagine, have much more processing capability, much more RAM, and probably much more hard drive space, SSD space than what you would have on a traditional CMTS. Is that a correct statement?
Yes.
So
Yes.
like kind of what you're talking about, John, with machine learning, or whether it's machine learning or whether it's truly AI, I would imagine you have much more an analytic capability on the CMTS, on a virtual CMTS, than what you would an analog CMTS because of that massive processing power on the server. So, when you're talking about load balancing on a traditional CMTS versus a vCMTS, this is some of the things that you're starting to realize in a vCMTS, that you can do this analytics and this, say, hey, I'm not going to use 687 megahertz anymore because I've been doing the trend analysis. I've been doing the analysis to say, we should avoid that frequency. Those are the things you're learning.
And even the load balancing, I was focused on the cable modem load balancing, sharing resources in a service group. You could take that a step further and say, here's my centralized server farm that has the compute power. How do I load balance the compute power? How do I move RPDs? Jason and I talked about this earlier this week about, would you generically allow RPDs to be combined to share resources, the CPU? Like if I have an RPD in Salt Lake City and an RPD in Atlanta, with DAA, flexible MAC architecture, distance is not really a limitation. And the cost of real estate, you could have a server farm with solar power, a solar and a server farm together in the middle of nowhere. That's cheaper. And then that's where all your servers are. And then you do DAA out to wherever across the United States. And there's no reason why we couldn't do that. The question would be, would you allow the RPDs to be combined to share the same resources if they had different delays? And that's the one thing we'd have to look at is one 2,000 kilometers and the other one's only 20 kilometers. Am I going to make the 20 kilometer RPD suffer because I combined it with an RPD that had 2,000 kilometers of SIN, the converged interconnect network delay?
Yeah, and not that I want to get into a MAC-PHY discussion here, but we talk about MAC-PHY being a great solution because it eliminates the distance issue, the timing issue associated with distance. When we talk about virtual CMTSs, and John, you're talking about going 3,000 kilometers to a remote PHY device. How does that impact things like latency and timing associated with it from a vCMTS to a remote PHY device?
I'll let Jason cover that one because he and I have just been talking about this.
Yeah, we've actually done some things with remote PHY and just seeing, pushing some of those distance ones. Obviously, you have to have a way. A lot of it gets into adjusting your map advance right so that your modem stay online. Probably when you're talking about those kind of distances, some type of a predictive or proactive grant scheduling would have a lot of benefits. And that's what we would do. When people start running these longer ones, we have something called DOCSIS predictive scheduling, where you could turn that on, and an algorithm looks at the traffic that's coming from the modem and makes a determination on when this modem might need a grant and sends it that way. So that's part of these long distances. I can tell you on the flexible MAC, and maybe we'll get to it. I'll kind of go into some details about how some of those microservices are kind of grouped, and how I think a flexible MAC would probably be a lot less difficult on a virtual platform than it would be probably on a chassis-based one.
Okay. Well, I want to tell us right now. We're on the topic. I guess we could just go there.
Yeah, I want to jump ahead. So some of it is, I forget, maybe it's 50 some odd microservices. So those functions that we had in DOCSIS that were embedded in iOS, took them and put them into these. And like you said, a microservice, is this concept where they're relatively stateless. They don't rely on other microservices, so that if it needs to reset, it resets. It doesn't mess up anybody else. And for Cisco, we took and divided those into 4 categories. There are control plane microservices. There are data plane. There's applications. Applications be things like packet cable, DOCSIS set-top gateway, etc. And then we have real-time services. The real-time services are things like modem ranging and upstream scheduling. Those are microservices in themselves. To do more of a flexible Mac type architecture, whether that goes into the RPD, whether it just goes into some type of other device in the field that front ends an RPD versus a flexible Mac RPD. Those are kind of options. But the thing is that software is already containerized. We're running it today on the CMBR, on the UGS or
On a
UCS
server,
platform.
right?
But if you need to push it out, you could certainly push that out.
Yeah, and when you push it out, that's what we generally call like edge compute, right? Where you're pushing those, right now we're in a virtualized environment, you're running them all on the server. But if you add more intelligence to that RFI node, it starts to become like a MACPHY node. And now you're just pushing those containers into the RFI or MACPHY node itself, which then becomes edge compute.
Right. And I mean, I always say it real simple. I'm sure there's complexities of getting all that to work together that I just kind of brush over because I'm not a programmer, but that is certainly the concept. And the fact that it's already in its own little container makes that a lot easier than if it's some kind of part of some other monolithic code. You got to try to pick out parts and pieces that you need to send out there.
Right. So we're pushing fiber closer to the home, and we're pushing our computational resources closer to the home, which just ultimately is going to make service ideally better for everyone. So conceptually, this all sounds really great, what you guys are doing. Are you actually, how's this going as far as like, are you just doing this in a lab? Are you doing field trials?
Right.
What's happening with this product?
Yeah, a little history on some of it. So we talked about that first 2016, and I mentioned that the cloud native one we showed in 2018. Actually, the cable access business unit within Cisco was kind of ahead of most of the other ones and actually deploying a cloud native, microservice based product. When we did that, then we kind of were picking out the Kubernetes and the Dockers and all the other kind of software, that the underlying open system software. We were picking that out, maintaining it. Cisco, as John was just saying, has a direction where a lot of things are moving to software. It's happening that for our 5G product. It's happening for the broadband network gateway products. So what Cisco within the service provider business unit said, hey, we want to come through and reset and basically have a group that's responsible for all those open system type, programs. And we're going to have, we call it SMI, subscriber microservice infrastructure, where Cisco is going to go back and build that as a certain way. And then individual business units within Cisco, like our cable access business unit, are going to go and build an application on top of that. So we started out with this cloud native where we were kind of doing everything from, picking out the Kubernetes and all the other programs in 2018. I think that kind of reset, and more into the 2020 timeframe, we rebuilt that to run on this SMI platform that was common throughout Cisco. And as far as deployment wise, I think it was just the earlier part of this year, John. I don't know, but it's been fairly recent that it was in some labs, but as far as actually being an orderable product was more into that time frame.
Okay. So, and do you guys sort of have like a roadmap of where you see the product going?
Yeah, most of the roadmap has been around scaling. So that was kind of as getting new processors in, new other type of UCS servers that we were using on it to move it to that and to scale from. And I didn't have those scaling numbers. I was going to try to look for them, but as far as from service groups, capacity that would be able to handle network resource, et cetera, those continue to go on there. The way we scale that product, a pod would have 3 servers on it. And that's kind of the way that you would deploy a Kubernetes type of deployment. And then as you scale, you add a 4th server, and that gives you the same densities you were getting before. So you don't have to keep growing in these groups of 3 on that. So those were kind of more the features on there. Some of the early deployments that we did with some customers, what we did, we have, and I don't know the count, John, but thousands of features on the CBR8 over time. If you look at them, the amount that are actually being used are probably 100 or less. John, what do you think?
Yeah, I would say out of all the features, we probably used less than 25% in most situations.
Yeah.
You know?
So where I was getting in that with the roadmap, there was never a plan from the start to go and look feature by feature and say, if we do this on the CBR8, we want to do this on the CMBR. John had even talked about it as well. The CMBR is, when we have our CBR8, our CMTS platforms, even the UBR 7200 back in the old days, these were built on a router platform. So when you build it on a router platform, there are certain things you have to do the way you address the interface and do some other things. And this was some of the things that John was alluding to. When we're on the CMBR looks more like a DOCSIS platform. It looks more like a layer 2 platform with minimal layer 3 things in it. So it makes it where when we build the interface, we don't have to follow the same rules we did on the CBR8. That's how come we have a lot more flexibility, that we don't have to go and pre-build bonding groups, for example. But those were some of the things. So like, we don't have to have certain things that we do with bonding groups as a feature in the roadmap on the CMBR. So the things that are on the CMBR now, DOCSIS 3.1 downstreams, we do the load balancing, some of those kind of things. What we don't have, for example, that's on the CBR8 is we didn't have OFDMA on there. And a lot of it was some of the initial customers weren't deploying that. So that's something that we're adding for the end of the year, because certainly now OFDMA has become a lot more of an interest topic. That's probably one of the bigger, things that you need on that platform as far as deployment wise.
Yeah, I mean, I'm kind of going under the assumption that this is a DOCSIS 3.1 virtual CMTS. That's kind of
right.
assumed. It supports OFDM in a downstream. How many bands of OFDM in a downstream?
I know the deployments we've done have done with 1. I don't know if I've turned up 2 in the lab when I've done testing on it. I know it does. I've seen like 48 single carrier. It does more than 32 single carrier forms, because there's some people that wanted to play with that. But I could tell you, adding some of those features are a lot easier, as it should be on the cloud. Just turn it up to, like a second OFDM channel.
Right. And on the upstream, OFDMA, you supporting OFDMA?
That's on the roadmap. I think that's on, I think it might be, I know it's later this year. It's within this year. I don't know if it was December or something even, quicker than that.
Yeah. How about SNMP support? Do you guys like do you support Cable Labs MiBs for complete integration with things like monitoring systems, PNM systems, things like that?
Yeah, no, we've kind of got away from that. And I know we talk about the CLI. We made a change when we moved to some of the things that happens with this microservices is that since they're not state-based, they're kind of reporting state as it changes to a central database.
Mm-hmm.
They also push that information out to streaming telemetry, and that's what that dashboard is grabbing when it's updating. So the benefits on that compared to SNMP, where you're kind of polling, this is more of a push model that's sending things out, and that's how we're sending out information from that. We're not doing SNMP MIBs. We're not supporting all the SNMP MIBs across the board. There are some though that we can do with. We have our dashboard we call Operations Hub, which goes out and is gathering that data, and it's possible to get that data from the Ops Hub that you need. There's been a few that we actually wrote and put it into a MIB format, so that Ops Hub is receiving the information, streaming telemetry, reformats it into that MIB, and then basically you're polling that Ops Hub to get that MIB for some of the deployments that needed to have some kind of an SNMP model for it.
Yeah, I mean, I'll let you follow up in a moment, John. There's a lot of operators that have SNMP monitoring systems.
Yes.
Do you guys think you'll have a roadmap where you'll eventually adopt SNMP MIBs, or are you just kind of saying we're not gonna go down the SNMP route? We're gonna stay with streaming telemetry from a monitoring standpoint. We'll get into your dashboards in just a second.
Yeah, no, that's a fair point. I think right now that's kind of our plan, is that we would like to stick with more of a streaming telemetry and kind of try to get away from some of the SNMP model.
Okay. I didn't mean to cut you off there, John. Go ahead.
It's fine. I cut you off all the time. We all know that. But Brady, that so many people do an SNMP, a full walk of all the MIBs.
Yeah.
And
I do it all the time.
And bring a CMTS to its knees.
Yep.
And it's like SNMP sometimes is more CPU than other processes going on in the background. And then you find out 5 different people are polling the same thing. It's like, wait a minute, we we found the enemy, he is us. It's our own doing, right? So by convincing that customer is a better way, and I think that's what Jason's getting at, is there's a better way than just doing SNMP and doing the polling and grabbing information and jacking up your CPU and affecting everything else. And this would be the way to do it, having this dashboard or the information being pushed out all the time, streaming telemetry. And maybe it's just a matter of education, right?
Yeah.
Teaching people that there is a better way.
So simple network management protocol, SNMP, I think it was developed in the 80s, mid 80s. It's been around for a long time. It's served us well, but it's very slow. I mean, it should be called slow network management protocol. However, it is widely adopted amongst pretty much every cable operator out there. It's embedded in products that I make for monitoring things. But I do agree. It's 2021 right now, and we're still using 1980s applications to monitor our stuff. I would actually support every vendor if they want to come up with innovative ways to stream the data back to us, to get it back to us, like someone like myself that runs a company called NimbleVis, that we aggregate this data. I'd like to get the data back much faster so it does not overutilize CMTS and cable modems. There's much better technology. So, I mean, I'd love to see you guys support SNMP so it supports legacy systems, but I'm also optimistic that you guys are looking at new technologies that can stream that, provided you document it well and make it open to vendors like myself who want to integrate that data with us. So speaking of that, that's why, kind of the title of this is this live stream is no CLI, because that's something that you showed during the ANGA COM. A bunch of GUIs to communicate, to set up and configure the CMTS, and no CLI. I'm like, Jason, how am I going to work with this CMTS if there's no CLI? So I'd like to talk just a little bit about some of the slides that you showed at ANGA COM, Jason, where there was no CLI to talk to the CMTS.
Does no CLI mean no leakage testing?
Different CLI.
You better specify command line interface.
Yes, good point.
Not everybody is an IT person, right? So a lot of RF guys see CLI and they think leakage testing.
Cumulative leakage index.
Where we're talking about the command line interface, right? Your actual commands.
Yeah.
So we're getting rid of all that.
So tell us about your dashboards that you had, Jason.
Yeah. So what we did is exactly with taking advantage of streaming telemetry is to move into more of a dashboard setup. I will say, just to kind of couch some of this stuff, there are APIs where you can interface into the CNBR or the Ops Hub. So the Ops Hub is kind of the dashboard management that's getting the data, and you could use APIs into the Ops Hub to get the data out, or you can use APIs to get directly into the CNBR if you want to get configuration information or something like that. So there's CLI-like things, but now you're using curl commands. You're using stuff that
you have to have some programming experience with.
I'm not sure if I want to jump into you're helping anybody by pushing into some other CLI. However, if you're a programmer, that's probably very, very comfortable with how you would get the data out of the system. But what we did do is we pushed more into using dashboards. So what we did is, and I forgot to count, say there might be 100 dashboards pre-built that you might get, like a list of modems, you might get like a modem verbose screen, you might get a copy of what the service groups configured like. And then within those dashboards, there'll be pointers that you could highlight on, or hyperlinks that will bring you to more detail. So if I'm looking at a cable modem and it lists that cable modem has 2 service flows in the downstream, if I click on that number 2, it'll be highlighted. It'll bring me to a service flow detail screen where I could see details about those particular service flows, like how much traffic's going through each one and these kind of things. And it shows graphically. It'll show, we use Grafana to display that information, but there's within the dashboard, you'll have an update time, but that's just the update that the dashboard's doing. We're getting real-time data all the time from the CMBR, just like when we display it on the screens. And you have the option on there then where you can go back, and if I want to look at a 10-minute snapshot of time to see how much traffic that modem's sending, I could do that. If I want to go back and look at a 30-minute snapshot of time, an hour. Those were things that we couldn't do in CLI very easily, that usually you would rely on, like you were talking about, some SNMP and some other third party or external applications to get that we can show a lot of that inside that dashboard now.
Have you had feedback from your current user base on, no CLI versus CLI on the CMTS?
Yeah, oh yeah. Yeah, I mean, that was some of that early testing. We actually got this product out a lot earlier. Like I said, when we were kind of early on, when we were still building our own from the cable access business unit, what we realized is that this is probably less of a change about how it operates as DOCSIS, because really all it was doing was going to provide the same kind of capacity that we were getting on the CBR8, but it was a different way that we were going to operate it from the customers. So we actually got it deployed early on with a customer in their lab, and then later on in some of their productions, to get feedback from them so they can say, hey, this is okay, this is not good for us. We have CSRs that need to get this data, customer service reps that need to get this data, and they get it from the CMTS, that they can't, this dashboard thing isn't adequate for them, or they had some homegrown programs. So we had a lot of feedback from them, and some of the dashboards were developed, specifically saying, hey, we need this type of application. So we developed a dashboard that would grab that.
Okay. So at ANGA COM, John Chapman had talked a lot about convergence and how, we have 5G, we have DOCSIS, maybe LTE, and cable operators should be looking to have basically duplication in their network. So if your DOCSIS network goes down, your 5G network can basically provide data to your subscribers. And similarly, if your subscribers' 5G network goes down, they can have backup from the DOCSIS network. One of the things that was discussed also at ANGA COM is with virtual CMTSs, they have the capability to not just be a DOCSIS CMTS, but also do other capabilities. They can, through software upgrades, they can become a PON CMTS, or maybe not a PON CMTS, but they can do PON computation. They can they can be extended to do 5G. Is that something that you guys are looking at?
Yes. So whether you do it on the same platform or whether you do it, I mean, when I say, I mean literally on the same servers, but that subscriber microservice infrastructure that I talked about, our 5G, cloud-based, control is on that same infrastructure that CMBR is. Although today, what we call the operations hub, kind of that dashboard, it manages the CMBR. We also have a smart PHY, configuration, automated configuration platform that runs on that. It isn't today, but nothing to say down the road that we couldn't get that a 5G, deployment to run that same operations hub as well.
So if I'm an operator and I'm trying to go to that vision that like John Chapman was painting, where we have redundant networks, and this isn't something necessarily we're doing today, but if I'm developing the network for the future, how do I do that where I have a wired line network and I have a wireless network that can cover each other? So if one network goes down, as a subscriber, I still have coverage in my home network.
Yeah,
I have that redundancy.
Certainly as a provider, I think having we talked a lot about a SYN or a converged interconnect network, and having that truly a converged network, not a purpose-built DOCSIS transport, I think would be the start if you're trying to provide that service. So that same converged, that same SYN would be able to service the 5G stuff as well as on the cable modem, the DOCSIS side. So certainly that as a provider, I think would be the start to have that on there. Whether it's fixed mobile or, I don't know on, some different ways you would deploy some of that. Obviously, some of the CPE might be different, and that might take some thinking on what that would look like actually inside the home, if you're trying to have one back up the other.
Right. All right, so I'm gonna be devil's advocate, and because John, I mean, normally you do a better job of this, but I don't want to buy a virtual CMTS because servers crash and hardware doesn't crash. Is that a good argument?
Hardware doesn't crash.
I've never seen a CMTS crash. Never ever.
Yeah. I would say if that's a fair argument, if you took if you took the same software that runs on a chassis-based CMTS and put it on a UCS server, I think that would you would probably have a concern with that. Because if a server crashed, that software really is reliant on high availability, where we're doing things like, for us, we will change, keeps maintain state between redundant supervisors, and that was all the thing that's part of how we maintain a high level of service with a chassis-based CMTS. Once we move to more where the software is rewritten, well, the software survives those servers going down. They're not all on one server. And to like what you were talking about earlier, when one microservice has problems, the Kubernetes just goes in and deletes it and builds it again, and then you're back to where you're growing, running things the same way. So the whether a server goes down, or whether a super whatever doesn't, what you're looking at is what do your customers see, and your customers are going to see that same high availability, whether it's running on a server software based or whether it's running on a chassis based solution.
Okay, well, maybe another argument is servers get hacked and the CMTS doesn't get hacked.
Yeah, I think there's provisions in there that you probably, I see some people whose CMTS is pretty loose, and they might not have been hacked yet, or maybe they just didn't know about it. So I think,
or they know about it and they don't tell anybody.
Well, it could be that too. But I mean, I see some with very little access control list, very little control plane protection, that kind of thing. So I think those same avenues that you have, the same things that you have to control a CMTS, I think you have that same ability to control on a server. Again, I think a lot of the deployments we're talking about today that we're looking at, those servers would be located on the provider's premises. They would have some type of access control that would limit who's getting into those servers. So I think you still have that same ability on both platforms.
Sure. So are there other arguments that you guys have seen, or maybe you're working out internally, as to what perhaps the future is for CMTSs, virtual CMTSs versus hardware, and why maybe an operator may choose a virtual CMTS over an analog-based CMTS?
Let me jump in. I mean, the biggest hurdle is you have to go DAA. You have to do digital fiber. Digital fiber means you have no more analog video. That right there could be the hurdle that you can't jump, right? You still have to provide maybe analog video for some reason. But we all know we're going that direction of digital video, and maybe as far as saying legacy digital video goes away as well. It's all IP. If you can go all IP, then things get more palatable. You can do it easier, but then you get the argument of, once it's all IP, I could do GPON, EPON, but now I have to run fiber all the way to the house, right? So everything has a price, and but to get to virtual and get to cloud, you have to take that first step, which is digital fiber. I have to get rid of my analog fiber links and go digital fiber, which to me shouldn't be as hard of a hurdle in that regard, unless you still have a lot of analog stuff you got to take care of, with spectrum monitoring and everything. I have a path track system in my head end, return path monitoring. Well, that goes away unless I have some type of NDF, NDR, or some way to digitize the analog signal, right?
Yeah. So I mean, I think that's potentially the biggest limiting factor, but I don't see that as a short-term limiting factor, because as service groups increase, as data rates increase, as we want to improve service to subscribers, a lot of people are going to be going to remote PHY. DAA is a good way to go, or we may see people going to MAC PHY. I think that's almost an inevitable direction that operators are going to go, until they finally say, we're going to go to fiber. And fiber is probably the ultimate solution for every cable operator to go to when they can afford it, and when they're finally driven to go there. So yeah, I think there's a lot of value in this.
I would agree. I would just even to kind of add on to John's, what I think some limiting things is that, we're all busy. All the providers are busy. And if you can work things in the platforms you have, there probably isn't as big of a driver to make these kind of big technology change. I think it's going to be when that happens. And that's to John's point and yours, both on, to get to this virtual, you have to make the step to some type of distributed access architecture. And if you're not ready to do that yet, and you have no driver from your marketing team or other type of things, ultimately customers, they want capacity and latency, concerns, and less concerned that, hey, this service needs to be virtualized or whatever. That's probably not a good selling point. So it's going to be more when those drivers like that happen. And I think some of the scaling numbers, I think certainly DOCSIS 4.0, when these kind of scale numbers come out, there'll be some, well, obviously to do DOCSIS 4.0, you need to move to a distributed access architecture too. And I think those are going to be some of the points in time that come that are going to be, hey, this is when people are going to make this jump because they need to. And then hopefully the benefits you see from some of the things like that dashboard is, maybe my operations become simpler. That, it's easier for me to get information out the system where I don't have to type command line to do it. And then maybe if the information's there, John had talked about too, maybe I could do some kind of artificial intelligence and maybe help troubleshoot problems quicker and those type of things.
Sure. Yeah. So if I'm an operator and I'm not at capacity, not going to be upgrading to either a new CMTS or virtual CMTS. But I am at capacity. I'm, from everything we talk about, I would really think virtual CMTSs are the future for upgrades, because I think they're going to future-proof you in a lot of different ways. They future-proof you because it's a software upgrade if you want to go from DOCSIS 3.1 to DOCSIS 4.0, as an example. It's a software upgrade if you want to go from DOCSIS to PON or DOCSIS to 5G. We talked about this in a discussion. I don't think you can do that same thing if you buy a hardware-based analog CMTS. You're locked into what that comes with. So virtual CMTS to me gives you so many more options and so many different directions to go to. You guys definitely have to get OFDMA in. I mean, that's obviously an obvious mandatory requirement. So when's that going to come out again? OFDMA?
This year, I think December is at the latest, but it's already scheduled for this year. I think what it actually is, there is an early release where OFDMA is there. We made quite a bit of enhancements to OFDMA on the CBR8, where we, do things like do a lot of profile IUC adjustments based on code word errors and all that. Those second rounds of features, I think, are coming in more on the December release. But I think that's probably needed for a production deployment.
Okay. And how much does your CMTS, the virtual CMTS, cost again?
Yeah. I think it's free.
I was going to get on you.
Free payments of $19.99.
All right. I like it.
500 customers that call in.
we
call in quick, folks. You only have a couple minutes left.
Make the checkout to see Ash. All
right. I like it. So guys, a few minutes left. Anything you want to promote coming up? Shows, anything like that? John, I'll let you go first.
I just did a live learning, so you should be able to get to that remotely. I think, what's it called? Live learning, SCTE. Steve Condra was on there from Teleste Intercept. I did a talk on there about 204 megahertz upstream, how we get there, what to look out for. And then Asaf from Harmonic talked about the stuff we're talking about now, virtual. And it was focused on how we pushing this 10G initiative, meaning 10 gigabit per second downstream, 1 gig to 5 gig upstream. How do we get there? What's our stepping stones? And what are our hurdles? And so I talk about that. From there, I also just wrote an article on 204, and I labeled it how to offer 1 gigabit per second on the upstream. 204 is the answer. And basically it'll be in the fall edition of Broadband Library. So that's coming out. And then Jason and I should be supporting the SCTE Expo, October. And I think Brady, you and I, and maybe Ron Hranek as well, should be on the Cable Games Celebrity Group team, or whatever they're calling it.
Yes.
Which is strange because it's listed for Wednesday, October 13th, I believe, at 8:30 a.m. I'm like, who does a Cable Games at 8:30 a.m.? I'm like, cable guys don't get up at 8:30 a.m.
I think that's part of the fun.
Yeah, we'll see how that goes.
Jason, yourself?
Yeah, I have been doing some work with John too. I've been doing some latency testing that I probably need to get some documents around it, whether it's in a webinar or something else, but maybe around some things on tuning some values that probably we may not mess with a bunch. Things like the data back off values and some other things like that, how that reacts when channels are full. John did a lot of work with some folks when, when we kind of had this last COVID, had a lot more upstream capacity that was getting kicked off, and what happens when a channel is really full and some of these with request grants. So probably getting together some data around that. As John said, we'll be at the SCTE. I think we'll figure out what we'll be demoing there. I'm sure this CMBR will be one of the products around that as well.
Okay, and myself, my next article in Broadband Library is going to be on virtual CMTSs and why I think they're pretty much the future of CMTSs and the benefits that they have to be. And then for Cable Tech Expo, I have 2 papers I'm doing, one on profile management application, and another one on machine learning and proactive network maintenance. And then, as John said, I'll also be on the celebrity cable games, which I think is just to show, guys like me who talk tech and DOCSIS and everything like that. They're going to show that because I don't actually go out and core cables and everything that every day, they're going to show just how bad I am at it. So I'll be coming in last on that, or maybe second to last next to John.
I can't wait to run an OTDR and try to do a fiber splice and core some cable. I tried to core some cable, hardline cable, at one of those games in like California years ago, and I torqued it so bad I broke the center conductor off completely. I was like, I just twisted it right off.
It's gonna be ugly. I mean, people should really come to watch us do these cable games, because they're gonna see some ugliness going on there. So it's gonna be a lot of fun.
We should be good at the Jeopardy game, and that might be it.
The Jeopardy I would rule at. The cable games I'm gonna drool at. So it's gonna be a lot of fun. So everyone who watched the show, please subscribe, like, and smash the thumbs up bell if you like the content. Greatly appreciate it. For you guys, great content today. So glad you gave us an update on the virtual CMTS. So glad you're staying in the game. I think it's going to be great stuff you're pumping out. So thanks everyone for watching. We'll be back in another month with more great content. So long, and see you later.
Take care.